Hello everyone, welcome to the demo video for my project, that is the geospatial sentiment analysis. So as you can see, I have created three modules here, the first one being the sentiment detection module, the second one being main, and the third one being the live sentiment plotter. So for this demo video, I'm going to be walking through the entire code with you, and then I'm going to be showing a plot as to how the actual code is running. So so let's come back to the first module, that is the sentiment detection module. So as you can see here, I have commented out most of the code because I didn't want to run the training part again, because for each classifier it would take like close to 20 minutes, and sadly we don't have that much time for the demo. So let's begin. So as you can see, I have created a voting classifier class where the first function being the classify, where it classifies the tweets based on the positive or the negative sentiments, and then the second function being the confidence, where it takes in the features and then calculates the confidence as to which classifier gave what value to each tweet, and then cumulative score of total votes divided by the number of votes we have. So let's start with the input data. So I have created two entries here, the positive ones and the negative ones, to keep the data separate. And then I'm creating a directory of trained classifiers where I'll keep the feature sets from each classifier and then use them again and again for running it on the actual program. So as you can see, the first part that I've done is the language processing, where I'm using the natural language toolkit, and I have separated out the sentences into tokens, and then from these tokens I've tagged those words into nouns, adjectives, and verbs, adverbs, and then I've taken out the relevant part, that is the adverb, verb, and adjective, as because these are the three main types of speeches that speech tags that gives the most information about the sentiment that is being expressed about a particular topic. So as you can see, first I have tokenized the words, tokenized the sentences and the tweets, and then I have tagged those words. So as a demo, I'm going to show you the same here. So I've already imported the natural language toolkit library that comes integrated with the Python. And let's say, for example, I have a case that is a variable that is a sentence, and it's a random string. So I'll start with the first part, that is the test, and the test variable, where I'll store the tokenized parts of the sentence. So let's do the same thing again, and I'll k.underscore tokenize, and I'm passing sentence as the parameter. Oops. And as you can see, the different words in the sentences have been taken out and separated, and now the next part would be to put them into the tokens. So let's say I'll do that, and I'll tk parts of speech underscore tag. That is a function that assigns tags to all the tokens. So let's say I passed my parameter test. So here you can see that different tokens have been tagged, and such as is a verb, or maybe a and this are determiners, random is an adjective, and test and case are nouns. So here we are most concerned with the is part and the random part. Probably random is the one that is giving out clear sentiment here, even though this is an arbitrary sentence, but in most of the sentences you might find adjectives to be giving the actual sentiment related with the sentence. So coming back now, here we have here we have another function called find features, where I'm taking out all the features from the given training data, and then I'm storing them into a list of words where I can differentiate between the positive words and negative words, and then assigning them a frequency as to how many times these particular words occur in a document, so as to have a feature as to which word occurring at what frequency would be positive or negative in a particular context. Now moving on, as you can see, I have used 7 classifiers here. So there's the The scikit-learn library comes with these classifiers inbuilt. So let's move a little bit up, and as you can see, we have all these classifiers listed that you can simply import and run a classification program on. However, it might be a little difficult to write your own classifier, and that would take the essence of the project, which is why I use the already existing classifiers to check the results, and I've used them multiple times to make a voted classifier. So here is the code for naive Bayes, and then the further classes of naive Bayes, that is MNB or Bernoulli's. And similarly, I've used logistic regression also, and stochastic gradient descent, then linear support vector classifier, and so on and so forth. So after that, coming to my last and most important function is the sentiment function, which will be taking in the input from the live values, so from the live tweets that I'll be extracting. And once I have those features, then I'm going to be using the classify function and the confidence function to calculate the positive or the negative sentiment here, and then return it with the confidence as to with how much confidence we can say whether the particular tweet is positive or negative. Now, coming to our main module, so here is a normal class that is listening to all the tweets, and I'm passing that tweet into my sentiment function that I just discussed now. And here I have kept a parameter as to keeping the confidence above 75%. Now you can alter that value depending upon how much accuracy do you want in your program. And once you have that, the last part that is most important is like what kind of topic that you're searching for. It can be a Twitter handle of any person, or probably a topic or a most trending hashtag. And lastly, the most important part again is the locations that we have to put in for geospatial tagging. Now, Twitter doesn't allow me to use latitude and longitudes straight away, so I have to convert them into geospatial coordinates. And definitely I can pass them through a text file, but that defeats the purpose of this demo as to show that these things actually work, and we can have a concatenated data from different locations. So let's try it and see what happens. Now I'm gonna run my main module. Main. So as you can see, first of all, it's gonna load the number of feature sets that it has been trained for. And yeah, so here are around 10,000 feature sets, and now the tweets are coming in. So as you can see, each tweet follows with a particular emotion, and as well as the confidence that with which we are trying to say whether it's a positive or a negative one. And now if I try to run the plotter for these live tweets, you can see that this graph is being created live. So on this part, as you can just see that with each tweet that's coming in, the sentiment is being analyzed. Now you're probably wondering as to why we have this part of the graph that has already been there. So the reason for that being is we are using the text file in the append mode. So the graph contains all the previous tweets that I've extracted and has already plotted that. And as the tweets are coming in, the old file is being added onto, so these tweets are being created. So that concludes my demo for the project. And lastly, as you can see, here is the confidence, here is the sentiment, and yeah, that should be it. Thank you so much for watching this.